So how can we do the follow-up question here, which says, can we solve it in one pass? And can we solve it in all of one space? So, well, one thing that comes to mind is maybe we could do this as we go, so not need an array, basically, to get this down to um, all of one space. So what if we just try like this? So zeros here, do one pass, and so somehow just count the ups. And so we could realize that both up and down become equal to 0 if so up and down values equal to 0 if, well, we know that certainly if this is equal, right? So if we have ai minus 1 equal to ai, then we have a flat, it's no longer a mountain, so immediately we can set them equal to 0, right? um or if we had, if we were going down, right, if we were going down like this, so if we're going down um like this, and then we had ai ai minus 1, right, the previous element smaller than the next element, right? So what this means is that we are going up, right? So we are like this, we are going like this, we are going up, and so it changed the direction, so it's no longer the same mountain, no longer mounted, right? It's just, it's kind of it's the start of a new one, right? Possibly of a new one, possibly, right? So what we can do in this case then is we can just null out both if down bigger than 0, which is when you are, in this case, you are going down, and this happens at that point, we can just put 0, or if they are equal, so we have a flat thing here, so it's no longer a mountain either, right? So what this would mean is that we could get rid of this and just here say both up equal to down equal to 0 if we have this here. And this is no longer, so just up plus 1, right? If this is the case, we just do plus 1. And then if it's the other case, which is if, so for down to be increased, we need this, the previous element, to be bigger, right? So we need this to be bigger. Then at that point we can do plus 1, right? And we no longer need to go from right to left. And now that we have both, we no longer need to wait until the end and compare. We could just right away here put res here and then check if we have a better mountain. So up plus down plus 1. And of course we need to do the same thing we did here, so we need to check if up and down. Only at that point we need to do that, right? And then at the end we could return that res and we could just delete this. And that's pretty much it. One thing we can do, but let's first run this before doing this, one more optimization here. What imbalance? Yep, so this is Ruby, not Python. So if this is the case, then we can do that. Okay, submit. Okay, so that passes, great. So one thing we can, and this is of n right time and of one space, right? Because we are using only 2 variables here. So that, yeah, fits the follow-up constraint. So one small thing we could do here, since this in Python, if it's true, it will add 1. So we could just do plus like this. And same thing for down. This is true. If it's true, it will add 1. If it's false, it will add 0. So we could just do that. And this should give us the same result. And we can submit. And that's successful as well. And so in terms of time, we just have this one here, one for loop that is doing of n, and we have only this extra space up and down and res. So we have of n time, and then we have of one space. And this is, of course, for the entire solution.